So what are redox reactions? Redox reactions are essentially reactions that involve the transfer of electrons from one substance to another substance. So in the idea of redox reactions, you will have one substance that's gaining electrons and you'll have another substance that is losing electrons. So let's look at this example over here of zinc 2 plus to zinc. Now, zinc 2 plus, it has a charge of 2 plus, but this zinc over here has a charge of 0. Now, how can we go from a 2 plus charge to a charge of 0? Well, if zinc 2 plus can gain 2 electrons, the 2 electrons will cancel out this charge of 2 plus, essentially, to explain it in a basic way. And then as a result, you get an overall charge of 0. When that zinc gains 1 electron, it will become zinc plus 1. But then when it gains another one, it achieves that 0 state. So in this case, when zinc is gaining electrons, we say that it is being reduced. So zinc 2 plus is being reduced. But let's look at the silver over here. Now the silver, we start off with a charge of 0, but then we become 2 plus. So over here we can actually see that silver has lost electrons because it has become more positive. Remember that electrons are negatively charged. So if we remove a negative charge from a substance, we move towards a positive direction. But when we add in electrons, we move towards the negative direction. Now, silver, since it is losing electrons, moving towards the positive direction, we say that silver is being oxidized. Now, to recap, zinc was gaining electrons, so it was reduced. Silver is losing electrons, so it's being oxidized. This brings us to a very important mnemonic in redox chemistry, and that is Leo says ger, or we can say oil rig. Both mean the same thing. So essentially, when we lose electrons, we become oxidized. But when we gain electrons, we become reduced. Same thing with oil rig. You become oxidized if you lose electrons. You become reduced if you gain electrons. And that's just a way to remember whether you are oxidized or are you reduced. Now, as I mentioned before, when you're being reduced, you are gaining electrons. Electrons are negatively charged, so you are moving towards the negative direction. But when we talk about oxidation, oxidation is losing electrons, so you're losing negative charge and you're moving towards a positive direction. Now, let's look at one more concept. And that concept is reductant versus oxidant. Now, this can be a little tricky, but it is super straightforward once we understand it. So reductant is essentially the substance that reduces another substance, but itself gets oxidized. Now, what does that mean? Well, a reductant. So when we talk about a substance, we can, if that substance is donating its electrons to another substance, so it's becoming oxidized because it's getting rid of its own electrons. But those electrons are going on to another substance, and that substance will be gaining electrons. So essentially what a reductant does is that it donates its electrons, it becomes oxidized, so something else can become reduced. So a reductant is the substance that reduces another substance, but itself gets oxidized. So once again, a reductant will oxidize. It will donate its electrons to another substance, and that other substance will be reduced. Versus an oxidant is the substance that oxidizes another substance, but itself gets reduced. So essentially, in an oxidant, so the oxidant is the one that will be oxidizing another substance. What does that mean? So the oxidant is essentially gaining electrons, but the substance that it gains electrons from is going to be the donator, and the oxidant is essentially getting reduced because it's gaining the electrons, but it's oxidizing that other substance, which means it's stealing away electrons from that other substance. Be careful not to get confused between the terms reductant and reduction, and oxidant and oxidation. Oxidation means you are losing electrons, and reduction means you are gaining electrons. And reductant is the substance that reduces, and oxidant reduces another substance, and oxidant is a substance that oxidizes another substance. Now let's take all of these terms and apply them into an example to really understand what's happening. So zinc 2 plus we start off with, and then we end up with zinc. So we can write this out, and we can say that essentially we are going from zinc 2 plus to zinc. So it's moving towards the negative direction. We started off positive, we moved towards 0. So zinc is gaining electrons, so it's being reduced. But copper, on the other hand, copper starts off with a charge of 0, and it becomes copper 2 plus. It's moving towards a positive direction, so it's losing electrons, and Leo says grr, so copper is being oxidized. So now, how can we identify the oxidant and the reductant? So over here, we can make note that here zinc has a 2 plus charge, and zinc over here has a 0 charge, so it gained electrons. So the donator of those electrons was actually copper, because copper lost 2 electrons and became copper 2 plus. So copper 2 plus was able to reduce zinc 2 plus, and as a result, we get zinc. So since copper is donating its electrons to zinc 2 plus, copper is the substance that reduces another substance. So it is the reductant. Copper is our reductant. And then by process of elimination, our zinc 2 plus must be our oxidant. Now, we can be sure of that by making note that copper over here started off with a charge of 0, then it became 2 plus, which means it lost electrons. Those electrons went to zinc 2 plus. Zinc 2 plus became zinc. So copper was the electron donor, zinc was the electron acceptor. So zinc was the oxidant. It oxidized copper, and copper was the reductant. It reduced zinc. And that is just the basic intro into what are redox reactions.